Today's video is on the power rule for monomials. The definition rule for the power rule is when you have a monomial raised to a power. You're going to usually see parentheses with this. What we do is take the base, in this case x, and we're going to multiply the two exponents together. Unlike product rule, when we add it, power rule, we multiply. Let's look at a couple examples. Number 1, x squared raised to the 5th. Here you see one base with parentheses. 2 times 5, you make x to the 10th power. Again, we're multiplying these exponents together. A visual way of saying this is like you having x squared, but you're doing that 5 times. So that looks like this, meaning that we have 5x squareds put together makes x to the 10th power. Let's look at number 2. Here we have a little bit of distribution going on. We have the exponent of 4 on the outside, so we have to multiply it not only to the m, but also to the n. Separately, that makes m, 7 times 4 is 28, and then n, 4 times 4 is 16. You can't combine these because they're different bases, they're different letters. Let's do the last one here. We have c d squared parenthesis to the 3rd power. This is power rule because of these parentheses. C secretly has an exponent of 1. So we have to multiply the 3 on the outside to both powers. C to the 3rd power, d to the 6th, because we're multiplying 3 times 1, and then 3 times 2. Leave it just like this in alphabetical order. Next up, we're going to talk about coefficients. We have coefficients in front of our variables. You're going to do the same thing with the variables, but you're going to raise the coefficient to that given power. Let's look at an example. Here we have 5x to the 7, parenthesis squared. We know what to do with the exponents. We know that's going to become 7 times 2, which is 14. But what we do with the coefficient is that we're going to raise 5 to the 2nd power. A very common mistake is that you would do 5 times 2 to make 10. That's incorrect. Let's do 5 squared, which makes 25. Next example, number 5. Here, we're going to do 2 to the 5th power, then multiply x squared and 5 to make x to the 10th, and then multiply, this is y to the 1st power here, secret 1, times 5 makes y to the 5th. Simplifying 2 to the 5th power makes 32. And let's look at some more examples. 6 looks a little tricky because we have a negative coefficient, but again, it's not too bad. Negative 2, you're going to square it. Because it's in parentheses, it's negative 2 times negative 2 makes a positive 4. Then we have p to the 4 times 2 is 8, and then q, 6 times 2 is 12. Let's look at an example, number 9, where we have a fraction coefficient. Same thing applies. We're going to raise 1/2 to the 3rd power, and then multiply all these exponents by what's on the outside, which is 3. A9, B12, and then 5 times 3 is 15. Some of you are not sure how to raise an fraction to a power. All we do is we raise the numerator and the denominator separately to that power. We're going to raise 1 to the 3rd power, which is 1, and then 2 to the 3rd power, 2 times 2 times 2 is 8. And you can leave your answer just like that. The next couple of problems are mixed practice, where not only do we have product rule, but we have power rule and adding or subtracting like terms as well. Number 10, You always start with the parenthesis part. Here we have power rule. This is going to simplify to x to the 9th power, y to the 9th power. And then separately we have times x, y squared. This is a throwback to our last video. This is product rule, where we have two bases and we're going to add the exponents. X to the 9th here, plus x to the 1st power makes x to the 10th. And then y to the 9th, plus y squared makes y to the 11th. And we cannot do anything else because they're two different bases. Number 11 is a good one because in this part with the parenthesis, there is a coefficient of a -1. I'm gonna write this -1 right here. So it's going to be -1 to the 4th power, -1 times -1 times -1 times -1. That's a +1. And then power rule a squared times 4 is a8. And then b with another secret 1 times 4 is b4. Done with the power rule. Now to multiply that by a cubed, which is product rule. We're going to add our exponents. A cubed plus a to the 8th is a11. And then since there's no b term over here, we're just going to leave it as b to the 4th. Let's do number 15, one that looks a little bit trickier at the bottom. Let's start out with power rule, simplifying this piece right here, distributing that outside 4 to everything on the inside. 3 to the 4th power, 3 times 3 times 3 times 3 is 81. And then we multiply our exponents. That is done there. Next piece, we have to simplify that through product rule and power rule. Let's just go step by step with this. Don't do too much at once. Here we have subtraction sign. Let's start here. That's going to make 49. X to the 10th y squared when we multiply that. And then separately we have times x squared y squared. Just like in order of operations, we have to do multiplication before subtraction. So I'm going to rewrite this 81x to the 12 y to the 4th, and then do this multiplication first. Here, that makes a 49, because 49 times 1, multiply the coefficients. And then I'm going to add the exponents from product rule. And perfect. We're left with an addition or subtraction problem. Here's subtraction problem, where you have the same base. Here we have x12 y4. Here we have x to the 12 y4. If they were not the same, we could not add or subtract these together. Because they have both the same letters and the same exponents, we can, in this case, subtract 81 minus 49. That makes 32. But a lot of us would want to subtract the exponents together. We do not do that with like terms, just like if we were subtracting 5x's minus 2x's. That makes 3x. You leave the x's the same. Same thing here, we leave the variables and exponents the same. And we're done. Circle that final answer. Write down what questions you guys have on product rule and power rule, and also combining like terms. I know we did everything in that one problem. Have a great night. See you guys next time.